Hello, my name is Kate Hessler. I am a junior at UL Lafayette studying mechanical engineering. This is my submission for assignment 3 for the mechatronics course. First, I would like to introduce the assignment. We have 3 parts. First part is to create a circuit that turns on and off an LED and adjust the brightness with commands sent through the serial monitor. Part 2 is create that same circuit that turns on and off the LED and adjusts the brightness with commands, except it's sent through Wi-Fi. The board must not be powered by the computer that is sending the command. We have to send the commands using processing only. Part 3 is to create that same circuit again, turning on and off the LED and adjusting the brightness with commands. But this will all be sent through a phone app. Today we're using Blink IoT. I'll show this physically later, but for the most part, the circuitry will remain the same through all 3 parts. The only thing that will change is after part 1, I will be taking this wire from pin 2, going to pin 1. That way, the onboard blue LED at IO2 right here is separated from the red LED, which is at pin 1. I did this because I wanted the blue LED that's built in to be a signal that everything's connected and ready to operate. And then the red LED is what I'm actually controlling in part 2 and 3. Using the Arduino online cloud-based software, we're able to write the sketches that will then be installed onto the dev module. However, I had problems with this. Once I was done writing my sketches and I would install it, which I'll show you how I was able to connect to the actual dev module here. It's very nice to use this cloud-based software. You can verify your sketches to make sure that the code will function properly, and then you can upload it to the device. But once I would upload it to the device and use the serial monitor, I was not able to adjust the baud rate. Therefore, the information in the serial monitor that would be uploaded from the dev module, you couldn't read it. It just wouldn't work. So I had to end up downloading the actual Arduino app to my computer, which seemed to work great. Here, I was able to use the serial monitor where I could adjust the baud rate to whatever I desired. Here we have problem 1 or part 1 of assignment 3, which again, to refresh memory, create a circuit that turns on and off an LED and adjust the brightness with commands sent through a serial monitor. Explanation of the code. First, we have a string to hold incoming data, just creating the string. And second line, whether the string is complete or not. We're then defining what each variable is. The built-in LED, which is pin 2. The pulse width modulation channel will be on I look at it as a slot 0. So we're utilizing channel 0 to send our PWM through. A frequency of 1,000 hertz. So it's going to do 1,000 cycles per second. That way, when you adjust the brightness of the LED, it looks smooth. And then the resolution of the pulse width modulation is 8-bit. The initial brightness, we're just setting that because this is a parameter that can be adjusted so that the LED reflects this number. We have 0 to 255, 0 being off, 255 being full brightness. That's due to the 8-bit resolution. And then this is the setup block. Here we're setting up the PWM channel, associating the channel, frequency, and PWM. The next line, we're attaching the designated LED to the channel that we used for the PWM. And then we're beginning the serial at this baud rate. Once this stuff has been completed, it's going to print out initialization complete into the serial monitor and ask for the user to enter a value 0 to 25, which will reflect or change the brightness of the LED depending on the value. Once you do that, it's going to print. It's going to pick up on that value, and channel 0, which since we set it here is defined, it's going to change that brightness to whatever value you put in there. And the loop, which happens continuously, once this portion is completed, it's going to figure out whether or not the data has been received. It's going to read the character, make sure that the string has been completed, and you have to take that character and convert it into an integer value so that it can actually change the brightness of the LED. We want to make sure that the value is actually equal to or greater than 0, but equal to or less than 255. Otherwise, we prompt to that that's an invalid input and that you need to enter a number from 0 to 255. So currently, I am connected to the module via USB and the COM8 port. I have already uploaded my sketch to the device, and here I can open the serial monitor, which is, you can see down here. And if I reset the board physically, you can see that initialization is completed, and you can enter a value from 0 to 255. So if we just put a value of, say, 100, hit enter, brightness has been reduced, it's set to 100. I'm going to switch to an external camera so that you can see this happen in real time. Here's the physical board, the ESP32-S3 dev module, USB connected to the computer. Off of pin 2, we have a wire going to a resistor. Then in series, the LED, which is then connected to the ground. The onboard built-in LED currently is programmed to operate at the same, operate in unison with this LED. For part 2 and 3, I'll be changing this wire to pin 1, so there are different variables. So just an example, right now, LED is off. If I type in a value of 100, turns the LED on. If I go to, say, max value, hit enter, it gets a little brighter. If I go to 0, it turns off. Here is the sketch for part 2, where we have to create a circuit that turns on and off an LED, adjust the brightness with commands sent through Wi-Fi. The board is not physically powered by the computer or connected through USB. It is just sending commands using processing. So we had to add some more code to be able to connect to the Wi-Fi from the port. I do already have the correct information uploaded on the board, but this would be the router name, this would be the router password. I had to add the definition for LED pin 2 so that they're separated. The initial brightness is 0 because it's going to start off. And this is the required code to get it to connect to Wi-Fi. This is all in the setup block. And once it's connected, it'll print out initialization complete and ask for you to send a value from 0 to 255, but in the processing program. And this is the void loop. Really, the only thing that changes is that it's going to be listening for incoming clients. The board itself, when powered independently from the computer, is going to be acting as the server. My computer and the processing unit is going to be acting as the client, sending information to the board for it to then process and output the light. Okay, now we have the red LED set to pin 1. So these are separate. I've already got my processing software connected. Had to use the IP given by the board, which you can see there. We've connected successfully. So if I type in a value here and send it to the board, you'll see that the LED turned off. This is all being done through the Wi-Fi connection. So if I put 200, light turns back on. For part 3, we had to use an app, and we're using the Blink IoT. So once I signed up for Blink, they sent me an email with some information that led me to how to set up my account to connect my device to the platform. And then they gave me the example code that I would then use to communicate between the module and the app wirelessly. And then I just had to fill in using the code I've already created to operate the onboard LEDs, what that looks like. So here we had to define quite a few different things: template ID, template name that I used in the app, and then the authorization token that I had to use to basically unlock the ESP32 with the app. We're importing the libraries for the Wi-Fi client and connection, and as well as the Blink library you need for the Wi-Fi and ESP32. Again, I've already put this data in correctly and uploaded it to the device. There are quite a few different new blocks here that weren't seen in the first 2 parts. Like we have a function to update the external LED output app display. And what we're utilizing in the app is a slider to adjust the light. We also have a few different nice things in the app to show us kind of what's going on with the board. And it's all used virtually, all able to be used due to these virtual pins. We're using virtual pin 0, 1, and 3. And then this block of code here is what's probably most familiar to the original codes from part 1 and part 2, where it's just kind of defining what the pins are and the pin modes and setting them to low. So the way that this code works is the LED is supposed to start, or the red LED is supposed to start in the off position. The blue LED represents the connectivity status. However, if you're in the app already connected and you have the slider value above 0, it's going to automatically update the color of the LED because the connectivity and the communication is just so fast. So I'm going to show you that. So again, here you can see that we're on standalone power. If I was to reset the board, sometimes it does have issues connecting, so I have to reset it more than once. Oh, there we go. So you can see that blue light indicates that the board is successfully connected to the internet and initialized with the Blink platform. You can see this is the app I designed for the module. Right now the red LED is off, but because the blue LED is on, we have connectivity, and you can verify that here by seeing that it's online, and then the connection time of when this successfully connected to the app. If we move this slider, it will directly change color or the brightness of the LED. And then this dial just is a digital representation of the brightness level. So if we go to max on the slider, it shows 255. It's at its brightest setting. And if we go to 0, it turns it off.